Gonna do a quick unit on, not unit, a quick lesson on the unit circle. And what you need to know about the unit circle is that it has a radius of 1. And that's a very, very, very key point. And so normally when we talk about trig, we say we have a right angle triangle, and let's say this is my angle, and I have an opposite side and adjacent side and hypotenuse. Well, when we look at the unit circle, and oh goodness me, I'm gonna do my best to draw a circle here. Yeah, it's not actually coming out all that bad. If I have a radius of 1, anytime I have an angle formed, I'm going to do this in a couple different colors. Here's my angle. Connected to that angle, I have an x-axis, I have a y-axis, and I have a radius. So my sine of my angle, theta, which is in radians, is actually equal to the opposite over the hypotenuse, which is my y value, over my radius. My cosine is equal to the adjacent over the radius, which is going to be, it's going to be on the x-axis over the radius, and the tangent is equal to the opposite over the adjacent, but my opposite side is my y value, and my adjacent side is my x value. And so what you have is sine, cosine, tangent. It's u run, x raised, u examine, which is how I remember it. So in the first quadrant, my x value is positive, x is positive, y is positive, and my radius is positive. My radius is always going to be positive. So I have a positive over positive, so sine's positive. X over r is positive, and y over x. But in quadrant 2, I'm on my negative. It's going to be in the negative axis, x-axis. So x will be negative, y will be positive, and my radius will be positive. So y over r is positive over positive, so sine's still positive. So they're all positive here. Second quadrant, sine's positive, but x over r and y over x will give me both negative values. In the third quadrant, both x and y are negative. R is always positive, but if x and y are negative, then sine's going to be negative, and cosine's negative. But take a look at tangent. You get a y over an x, which is a negative and a negative, which is positive. So the third quadrant, all my tangent values are positive. In the fourth quadrant, I'm going to have the x value will be positive, the y value will be negative. Quadrant 4, x is positive, y is negative, r is still positive. So this is going to be negative, that's going to be positive, and that's going to be negative. So in the fourth quadrant, only cosine is positive. So all students take calculus, is the way I remember it. And that's it. So in order to find the value, the terminal points, you have to remember it's the Pythagorean theorem. It's going to be a squared plus b squared equals c squared. Well, my radius is 1, so c squared equals 1. So c equals 1. And here's the deal. It's actually pretty easy. In order to find the terminal point, you find the cosine of the angle and the sine of the angle, and that gives you your terminal point. There are ways to find exact values, but it's going to get into and make this video really long. And so if you are curious into finding exact values, actually, you know what? Maybe we'll have some time to do this. Pi over 6 is 30. Pi over 4 is 45, and pi over 3 is 60. Pi over 2 is 90. And let's see, this is going to be 5 pi over 6. This will be 3 pi over 4. This will be 2 pi over 3. This is pi. This is going to be 7 pi over 6. It's going to be 5 pi over 4. This is going to be 5 pi over 3. It's 3 pi over 2. And then 11 pi over 6. 7 pi over 4. And 5, 7. 1, 2, 3. 7 pi over 3. 1, 3, 5. 1, 3, 5, 7, 5, 5. Oh, I'm sorry. There's a mistake here. I knew there was a mistake someplace. This is 4 pi over 3, and this is 5 pi over 3. And I'm going to show you how to do these. This is all in quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. You do need to know your special right angle triangles. And if you do, then you're going to be in great shape. And special right angle triangles look something like this. This is pi over 6. This is pi over 3. This is 1, 1/2, and radical 3 over 2. This is pi over 4, which makes this pi over 4. This is 1. This is radical 2 over 2. Radical 2 over 2. And so these are your reference angles in quadrant 1. If you're looking at 5 pi over 4, you're in the third quadrant, but you're going to use the reference angle of pi over 4. And so if I had find the terminal point for, well, let's say 5 pi over 4. That means the cosine of 5 pi over 4. So I go to pi over 4, and it's going to be cosine is going to be adjacent over hypotenuse, so it's going to be radical 2 over 2, comma, and the sine of 5 pi over 4 is radical 2 over 2. But because I'm in the third quadrant, only tangent's positive, so these are both negative, and that's it. Now, in order to get these, because 6 has 2 and 6 have a common factor, 3 and 6 have a common factor, 4 and 6 have a common factor, but 5 doesn't, then it's 5 pi over 6. 6 and 6 have common factors. 7 does not, 8 does, 9 does, 10 does, but 11 does not. 2 has a common factor, 3 does not. 4 has a common factor with 4, 5 does not. 6 has a common factor with 4, but 7 does not. 2 does not have a common factor with 3. 4 does not have a common factor with 3. And 5 does not have a common factor with 3. So that's how I got the numerators. Let's see, how much time do I have? Oh, that's about it. Alright, well, I hope that was useful. Good way to find the terminal point and the